Oh my goodness. What we're about to do in this video is going to blow minds. We're going to prove that the sum of a converging geometric series does indeed converge to the first term over 1 minus r. Given, again, that we've got that the absolute value of r, our common ratio, is less than 1. Let's see why and how this works. So what we do is we actually start out by expanding this out. So what is that going to be? Well, it's going to be a sub 0 plus a sub 0 times r plus a sub 0 r squared. All I'm doing is plugging in the next term each time and multiplying by r each time. R cubed plus dot 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 plus, and then we'll do the n minus first term and then the nth term like so. That's going out to infinity, and that we'll just call is equal to s sub n, right? The sum. Now, let's take a look at this thing right here. How are we going to go from here and find the sum in a different way? Well, watch what we can do. And this was a really nifty idea that someone had many years ago. We can multiply that whole equation by r. Right, we know this is the sum, right, as we expand it out. So we're going to multiply by r. It's going to give me a sub 0 r plus a sub 0 r squared. Every term gets multiplied by r, so every term has an r value going up by a power of 1. A sub 0 r to the fourth plus dot 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 plus a sub 0, this would be r to the n, plus a sub 0 r to the n plus 1. Okay, let's see where this thing goes, shall we? We shall. So what we're going to do next is we're going to realize that we have a lot of matching terms here that will cancel out. If only we could subtract two equations that are true. Could we do it? We can. So we're going to subtract both equations. S sub n, the sum that we want, minus r times s sub n is equal to, watch what happens when we subtract this minus that. The a sub 0 has nothing to match up with, so it's still a sub 0. A sub 0 r subtracts with that. A sub 0 r squared with this. A sub 0 r cubed with that. A sub 0 r to the fourth with a sub 0 r to the fourth. A sub 0 r to the n minus 1 with, well, there was an n minus 1 there, I promise you. A sub 0 r to the n, they cancel, minus a sub 0 r to the n plus 1. Oh boy. And then from here, we want s sub n. That's what we want to solve for. That is the sum that we're solving for. So I'm going to factor out s sub n. That is equal to the sum, right? That's what we've written out here. So that's 1 minus r. That's the key idea here, is we're just defining the sum as some big thing s. So we've got that. Let me make the parentheses a little nicer. Is equal to, and I'm going to factor out an a sub 0 from this. 1 minus r to the n plus 1. Now remember, it's important that we note that the absolute value of r is less than 1, because that's where we know that this thing converges. By the nth term divergence test, we diverge if we were equal to 1 or more. So we've got the absolute value of r is less than 1. So s sub n is therefore equal to a sub 0 times 1 minus r to the n plus 1 all over 1 minus r. Now, an important note here, if you need to find the sum of a finite series, a finite geometric series, this is what you use, this formula. It'll work no matter what the r value is. But as we're going to infinity, r, the absolute value's got to be less than 1. So I'm going to take now the limit if we look at this. So the limit as n goes to infinity of all of this, of s sub n. Well, a sub 0 is some constant. Remember that r to the n plus 1, that's some number. So that's a number that's less than 1. So r to the n plus 1 is going to be like, I don't know, think of it as 1 over a number greater than 1. Let's just do 2, for instance. Well, if I'm doing this as it goes to infinity, that's like taking 1/2 and repeatedly multiplying by 1/2. It's eventually going to go to 0. So that goes to 0 right there. Isn't that awesome? And we're just left with 1. 1 minus 0. And that times a sub 0 is just a sub 0. All over 1 minus r. Get out of town. So basically, again, the idea is that the absolute value of r is needed there, because it could be a negative r value. Negative 1/2 is fine too. Even if it alternates, it's going to converge. It's the fact that this part here goes to 0 because the absolute value of r is less than 1. It could be any fraction. It could be negative 1/4. Well, if I raise that to the infinity, that, even though it's going to alternate, positive and negative, will eventually get so big in the denominator. And this is going to be 1 or negative 1 over huge goes to 0. And that makes this go to 0. 1 minus 0 is 1. leaving you with a sub 0 over 1 minus r. Get out of here. It's so awesome. That just proved that the sum of an infinite geometric series is the first term divided by 1 minus r. I will see you in the next video. It's awesome. Maybe not as awesome as this one, because I don't know if anything can compare to that. I'll see you later. Peace.